Hello everyone, my name is Viraj, and today we'll be looking at the very first problem from the CP-31 sheet by TLE Eliminators under the 800 rated questions. Let's begin. So I'll be moving on to the CP-31 sheet to find my problems. I have ticked off the 800 rated parameter over here, and I can see my clickable links. Here is my first problem. Let's open this. Halloumi Boxes. All right, let's see the problem. Theophanis is busy after his last contest, as now, and he has to deliver many Halloumis all over the world. All right, he stored them inside n boxes, and each of them have some number AI written on it. Fine. He wants to store them in non-decreasing order based on their number. However, his machine works in a strange way. It can only reverse any subarray of boxes with length at most k. So this is a very important point they have given. One thing they have said is subarray, and then they have said something about at most k. So we'll understand that briefly in the next part. Let's see what are they asking. They are saying find if it's possible to sort the boxes using any number of reverses. So if I can say that this is an operation, that is this reversing of that subarray of length at most k, then I can call this operation as many number of times as I can. And if I'm able to sort the array, I think I have to print a yes, correct, in the output, else I have to print a no. All right, great. So I think that I have read the question, and now let's try to analyze this question, in a very generalized way. Okay, so I'll take up an array over here. Let's say I have an array A. So let's say the elements are A0, A1, A2, A3, so on till AN. These are my numbers. All right, or AN minus 1 to be specific. I can say that I have n numbers and I have done a zero-based indexing. Now, besides this array that is given, this is like kind of the boxes which are given to you with each and every number. I can say that I have been given one more parameter k. Now, what is this parameter? It is basically a parameter related to subarray. So first understand what is a subarray. Let's see. So a subarray by definition means a segment taken out from the array which hasn't been changed in order, where you take out some elements from the start, take out some elements from the end, and then you just pick that segment from the array itself. So let's say I have taken out some elements from the start, that is I don't take A0 and so on. And let's say I take out some elements from the end, let's say I don't take this portion. And this segment between this without changing the order is a subarray. So I'll say this is a subarray, I'll write this down. Subarray is A1, A2 and A3. All right, so now we have understood subarray. Now, of course, since this is part of the array, this is going to have a size. In this case, I can see the size of this is 3. And related to this size, they have actually given the parameter k. They are saying that you can take out or consider a subarray of at most k size. Now, what does at most k means? If let's say the size of this subarray is, let's say, x, then you want x to be less than equal to k. This is what they're trying to tell you. So if let's say I have, in this case, I've taken the subarray to be size of 3, I know that k is going to be, like, I know 3 is less than equal to k. So if let's say k is given to you, let's say assumably, let's say 5, that means you can take at most 5 size of subarray. So you can take 1, you can take 2, you can take 3, you can take 4, you can take 5, but not above 5. You want a size that's less than equal to 5. Maybe you can even go with 0, but definitely not above 5. So in this case, I can say I have taken a subarray of size 3. All right. So I have understood this at most k term. Now, what are they saying? After you've taken the subarray, what do you want to do? Or what have you been told to do? We can reverse this subarray totally. So what does reversing mean? Now I'm going to analyze the array from the right hand side. So if let's say from the right hand side I wrote it like A1, A2, A3. From the right I'll write it like A3, A2 and A1. Alright, this is the reversing. And after I've done a reversal, you can say this initial array has been modified. Now the elements don't at all look like A1, A2, A3, rather they looks like something like A3, then this is same remains A2, not a problem, and this becomes A1. All right. Now this particular thing that I just did over here, we can say that this is called an operation. And this particular operation can be done any number of times. And since this can be done any number of times, all they are asking you is, can you sort the array in a non-decreasing order? In a non-decreasing order. Now, non-decreasing might be confusing. Simple non-decreasing means increasing order. If it's non-decreasing, it's increasing. So I can say I simply want to check whether I can sort in an increasing order or not. And if I can sort, I would want to print a yes, yes, yes. And if I cannot sort, then I want to print a no. In this case, I want to know. All right, great. So now I have understood the question and I have also taken a general explanation. What I can do is we can now look at some test cases and analyze what are they trying to tell us, where is it a yes, where is it a no according to them. All right, so I'll go back to the problem. We'll see some test cases. Let's pick up test case number 3. All right, so I'll move over here. What have they given you? They have said that n is equal to 4, k is also equal to 4. And then what they have said, the array looks something like 6, 4, and then 2, and then 1. So what they mean to say is you can take at most 4 sized subarray. So that means I can take 1, I can take 2, I can take 3, I can take 4. Now, if that is the case that is given to me, what I can do is, I am not bothered about the number of operations as of now, but let's just look at one of the solution. I can say that maybe I can choose to take a total subarray size of 4. That is choosing this subarray itself. Now, if I take this as a subarray, if I reverse this, the subarray looks now like 1, then you have 2, then you have 3, sorry, not 3, then you have 4, and then you have 6. And in this case, now you can very well see that the array has been sorted in a non-decreasing order, which means by using just one operation, again, not bothered with the number of operations, but still by using one operation, I know that I have created, like if I took this as a segment totally, let me write this. If I have taken this as a segment totally, I know I am good to go. Since the subarray size is 4, I can definitely go till 4, hence this satisfies the condition. And taking this total as a segment of 4, I can see that I have reversed this. This is now in a non-decreasing order. So the answer to this question becomes yes. That yes, using some particular operation, I was able to achieve a yes answer. So I can see, I think the answer to the third case is definitely yes. All right. So now we have understood the problem and one of the test cases. What we'll try to do now is understand ideas. Let's see first, what is the input that is given to us? Why? Because input is going to help me analyze the expected time complexity, which is very important to formulate any further idea, right? So let's look at the input. I have been given test cases of total 100, all right? And I have been told that time limit, per test case is 1 second. What does this mean? I know that by fact, 1 second requires me or gives me the power to hold a total of 10 power 8 operations, correct? And if I have been given 100 test cases, that means for each test case, I am required somewhere around, or on an upper bound of course, I'm required somewhere around 10 to power 6 operations available. Now let's look at the n and k given to me. So n and k both are in 100 order, which is very small. So now that you think, if you create a solution, your solution can definitely run in maybe O of n cube. Yes, it can run, because if n, I know if n goes in 100 order, then I know O of n cube will go in 10 power 6 order, which definitely satisfies my condition, since I am allowed to do this much number of total operations or go up till this complexity per test case. How about anything lower than this? I can even go for n square. Definitely, because n square is less than n cube. So this maybe goes in 10 power 4, still good to go. And anything below this, maybe O of n, good to go. Maybe O of n log n, definitely good to go. So anything that comes below n cube does make sense that this will work. Given I have fully understood the current parameters, that is n being in 100 order. Again, maybe this was also related to k, then k is also in 100 order. It's just that I want to go in a full order of 3, as in power of 3, that gives me somewhere in a 10 power 6 solution. So that definitely works. Now, this being my upper limit, I of course don't want, or I can say that I want to make a solution like this. Maybe I can create a solution that works faster than this. That's not going to be a problem. But in my mind, I know that even if I go to this limit, I'll be still good to go. So this helps me create some ideas. So I'll write this over here. This is kind of my expected time complexity. Expected time complexity. Up till this limit, I am good to go. All right, cool. So I know that in my idea, I have something formulating. I know I can go to a very brute order of n cube also. Great. Now let us look at the next page. What should we now think, and how should we finally approach this problem? All right. So now this problem is about yes and no, correct? I have to print somewhere in yes, somewhere in no. So it makes sense that I will have some cases, right? Some case making would be very great to begin with. All right. So let's try to make some very, very simple cases. So of course I have the array, and that array will have, in my head, it can have one of the two nature. All right. let's discuss what two natures am I talking about. So I'll draw these two cases. One nature will obviously be the array can be sorted. As in, as soon as the array is given to you, you realize, okay, the array is already sorted. And the other nature, of course, becomes the array is unsorted. These are the only two viable cases I can distribute my array in. This is case 1, this is case 2. Why have I done this is because I know inside my head one thing for sure. If I look at case 1, if the array is already sorted, can I say that my answer is already yes? Correct. I can. Why? Makes sense, right? If the array is already sorted and you were asked how many, you were asked, can you actually sort this? If the array is already sorted, you can obviously sort this, right? You can just print the array itself and yes, it's sorted. So I know if the array is already sorted, I don't need to do anything. However n is given, however k is given, whatever is the array, if it's sorted, answer is blind eye, it's yes. Correct. So I know I can create a yes over here. I can say yes to this particular solution and I'll be good to go. That means all that is left for me to discuss is what happens if the array is unsorted. If the array is unsorted, of course I want to do something. Correct. Of course I want to approach this problem in such a way where I can actually do something on an unsorted array, because for sorted arrays, answer is always yes. So let's discuss this. I'll again bifurcate this into two cases. Alright, I'll again bifurcate this into two cases. We'll see what cases am I talking about. So, of course, when the array is unsorted, you have to make some changes. To make some changes, you are given the operation of reversing the subarray. And there is a parameter that's fixed to that particular power that has been given to you. That parameter is k. So that means there is some dependency on k. I know that. Let's start off with the very base case of k and maybe I can formulate my answer from there. So let's think about very basic. What if k is 1? What if k is 1 given to you? If k is given 1 to you, let's try to analyze this. So I'll take up the test case again. You have this array over here. Array is 6, 4, 2 and 1. Now, if you have been given the array that looks like 6, 4, 2 and 1, this is definitely unsorted. You know very well this is unsorted. Now, because this array is unsorted, you want to sort it. What is the physical meaning of sorting? You understand that some element which is not at its desired location has to go to its desired location. That means 6 over here technically should be at the very last, since it's the largest element. So after sorting, I know 6 goes to the very last element. 1, let's say, has to be at the very first place. 4 has to be at the third place. 2 has to be at the second place. So you know there is some element in this array which needs to be at some place, but currently it's not. So I want to make it go to that place. But the problem over here is, remember, I have been given k equals to 1. I have been given k equals to 1. Now, if k is 1, essentially that means you can only take segments of at most k length. And k being 1, either you don't take any segment, that's 0 length, or you take a segment that's only of 1 length. Now, 1 length segment simply means the number itself. So if I take this segment like 6, or like segment like 4, or 2, or 1, what essentially happens? What happens when you reverse an subarray of size 1? The element doesn't change its location. It remains there. So if I want to reverse this segment, 6 still remains over here. If I reverse this segment, 4 still remains over here. If I reverse this segment, 2 still remains over here, and so on, so on, so on. And remember, I want to shift 6 somewhere. I want to shift 4 somewhere. Am I being able to do that? Or in a very generalized case, can I say that if k is given 1 to me, I have the power to shift any element from anywhere to anywhere that I want? No, I absolutely don't have that power. That means if k is 1 and the array is unsorted, can I say that the answer is always no? Yes, I can do that because it makes sense. I did not even have the power to shift any element from any position to any position. How will I actually make my array from unsorted to sorted? Not at all possible. Great. I hope this idea is clear. Now let's move on. Now, since we discussed k equals to 1, the other case is going to be cases where I think k is 2, 3, 4 and so on. So let's bring up a generalized case in this. What happens when k is greater than 1? Alright, so let's look at that one by one. We'll see over here. I'll again take the same case and I'll rub it over here. I'll say, okay, what happens when k became 2? That means you had the power to swap, or you can say reverse, a subarray of at most 2 length. Now, at most 2 means 0, 1 or 2. Now, 0 is of course not beneficial. 1 we just saw was not at all beneficial. What about 2? What happens when you select a segment of 2 size? Let's say I pick up 6 and 4. Essentially, when I say I reverse this array of 6 and 4, I know that the 4 goes to this location and 6 goes to this location. And what essentially has happened over here, you can see that in a 2-size subarray, indirectly, the elements have swapped their places. Can I say 4 came over here and 6 went over here? Yes, I can say that. Similarly, if I would have picked up 4 and 2, 2 would have come over here, 4 would have gone over here, and so on, so on, so on. Now, how is this beneficial? Let's start thinking. Can I say that for k equals to 2, do I get the power to place any element from any location to any location that I want? Let's see. Currently over here, let's imagine that you want to shift 6 at the location that is over here. That's the last location. Of course, I can do that. How? Let's imagine. What if I select this segment first? I reverse this becomes 4 and this becomes 6. Let's write this down. So this becomes 4, 6, 2 and 1. Let's say I pick up these next 2 elements. So what happens this? This is 4, this is 2, this is 6 and this is 1. How about these 2 elements now? This is 4, this is 2, this is 1 and this is 6. Voila. Can I say that by using a 2-sized segment, I have finally made 6 go to a location where I finally wanted to go? Yes, I desired the 6 to be over here and I have done that. What about next part? Now that 6 has reached its desired location, can you argue in the same order that if you want to make 4 go to its desired location, as in now the array looks like this. So can you say if I want to make 4 go to its desired location, that in this case is at the 3rd location, can I do the same thing? Can I start taking up 2 2-side segments, let's say 4 2 swapped, 2 1 swapped, and will that make my 4 go over there? Of course. Let's say if you take up the first segment, this would transition to look like 2 4 1 and 6. Then you take up these 2 numbers as a segment and this becomes 2 1 4 and 6 and so on. Next time, if I take up the possibility to shift 2 to its desired location, that is at this place, what do I essentially do? I will simply take these 2 segments, this one segment of these 2 numbers, 2 and 1, and this becomes 1, 2, 4 and 6. And good to go. Am I good to go? Yes, I have sorted the array in a non-decreasing or an increasing order, which means that by taking 2 lengthed segments, I am having the power to somehow shift any element to any other place where I desire. And this power is indirectly helping me to say that yes, I can sort the array if it is unsorted and if I am taking k equals to 2 every time. As in if I'm always selecting 2 lengthed segments, I'll be good to go. I can sort any unsorted array in whatever number of operations I want. And since number of operations is not bothered by me, the full and final answer is basically, can you sort it? I can say answer is yes, and so on. Alright, so this makes sense. Now, let's write this idea. I'll write this idea over here so that it becomes clear. If k equals to 2, I can say I have the power to make any element move from current position, let's say I'll call this pos, to desired position. All right, this is the main idea behind this problem, right? So I have very well solved my particular question when it comes to saying was K2 correct? For K2, I know that I can say the answer is I blind always yes. All right. So in this case, I just discussed for k equals to 2. So I'll say answer is always yes. All right, great. But what about k equals to 3, 4, 5, 6, so on? Remember, you are said that if let's say k is given 4 to you, you want at most 4 length subarray. You cannot go above 4. In that means you can take either 0, either 1, either 2, either 3, either 4. So now 1 was not helpful, 0 was obviously not helpful, but was 2 helpful? We just saw that for k equals to 2, we can always sort an array. Why? Because I get the power to shift any element or move any element from its current position to a desired position. That means if k is given some number above 2, can I still say I'll be taking k equals to 2 sized arrays only or 2 sized sub arrays only? Yes. And by doing that, will I always make sure that for any k value above 2, I will still take k equals to 2 and I will still get the answer as yes. Correct. That's the idea. So if I generalize this now, I don't need to only say that the answer is yes for k equals to 2. Rather, I can say that if k is if k is greater than 1, as in 2, 3, 4, if it's 2, I obviously take 2. But even for 3, 4, 5, 6 and so on till 100, that's the maximum k, I will still fixate with k equals to 2 and I will always create a possibility to make my answer go to yes. Always able to sort this out. Alright, so this is the whole idea behind the problem. That means if I finally justify this, what can I finally say? The answer is yes if the array is already sorted, pretty obvious, or if the array is unsorted but k is greater than 1. So if k greater than 1, print a yes. If sorted, print a yes. Only and only if it's unsorted and k is 1, then print a no, because if it's unsorted and k is 1, you never have the power to shift any element from any location. How will you sort it? Not possible. We will print a no and good to go. Alright, so now what we'll do is we'll quickly look at the code part to understand how can we inculcate this whole idea into implementation and code. Alright, so this is going to be the code for this. Let's see. Very simple. I have taken the test cases, ran a while loop and finally went inside every test case. I now am taking input, taken n, taken k, taken the input of n and k, declared a vector and then taken that vector as input. So this up till this is all about taking inputs. Now moving on. What I have done is I have created a copy of this array. So by simply writing copy a, that's a variable name I take, I said copy a equals to a. That means now copy a stores exactly a as it is in a copy format. And then I'm going to call an STL function of sort and sort this copy a from start to end. This creates a sorted a indirectly for me that is now visible in copy of a vector. And why am I doing this? Because I want to check whether the initial array was sorted or not. So how do I check that? I'll say, is my copy of a, that is the sorted a itself, equal to the initial a, that's a itself? If it's equal, or if k greater than 1, in both two cases, remember, I wanted to print a yes. So I'll say, okay, if copy is equal to copy of a is equal to a, or k is greater than 1, I know I will print a yes. Else, this case is only when I say array is unsorted and k was 1. In this case, I print a no. And I'll be good to go. Alright, so this definitely passes the sample cases and it's going to pass the correct all the cases and get you an AC on Codeforces. Alright, so let us look at the time complexity now quickly. Now as we discussed, this taking loop of the array input itself, this is n order, correct? Now you are creating a copy of the array. This can be also said of n order because this requires copying each an element every time. And then this STL function runs in the backend in n log n order. So you can say this is n log n, where n again is the size of this array. And then these are simple checks. This check, however, since you are checking the equivalency between two arrays, this would be taking an n order again, because in the backend there would be something like running a loop and simply checking element one by one and one by one. So I can say this is again a check of n order and I'll be good to go. So overall, now that I have written down the complexity of each and every possible operation that we are doing, if I write the final time complexity, I would be required to take the highest order in this case, which means I are required to take n log n, since n log n is the superseding term as compared to everything else. And now this definitely works. Why? Because I know I have a 100 size of maximum n. That means this would be something like log, again this is log base 2, and this would be 100 log base 2, or of 100 you can say, which essentially would mean something like 100 into 7, like 100 log base 2 of 100 is approximately 7 to 8 iterations. So this would somewhere go to 700 iterations, which is again good to go, of course, because I know this is well within my boundaries. I had a maximum limit of something like 10 power 6 operations we discussed per test case, but in this case per test case I'm only taking 700 iterations. All great. What about space? Of course, I'm dependent on the space when I'm taking a copy of this array, and if you would have also considered the space for the input itself. So you can say space is dependent on the size of the array, which is again in worst case O of 100. So you can say 100 size space. Again, we can just avoid to report it like this. O of n would be a good parameter to report on the basis of space. Again, within my boundaries, definitely getting me an accepted solution, not a TLE at all. All right. So this is what wraps up our whole problem. And now we have realized how we can solve yes and no cases by case making. You can understand that, okay, I wanted to do this, hence the answer was yes. If this was already there, the answer was no, and so on, so on, so on. All right. So I hope you liked the video. Thank you for watching.